Hey everyone, welcome to the ecosystem track. It seems that Sean over here has been warming me up sufficiently. My sincere apologies for the carrots and the turkey wraps. We had nothing to do with that here at Docker, but let's give them a warm welcome, show them that we're excited. We've seen a lot of great stuff from Microsoft, and I'm sure we're about to have a pretty awesome talk. So big round of applause.
Thanks, man. Just for the record, I'd like carrots. All right. So I'm going to spend the next 40 minutes trying to just cram about 80 minutes of content in here, talking about a couple of tools and the developer experience with Azure. Is anybody currently using Azure for container development right now? All right, that's good. Good portion of the room. We have a lot of ways to do container development, a lot of different types of tooling when it comes to Azure and doing container development. My name is Shane. I'm a developer advocate on the Azure team, and my job really is to talk to the community and kind of be your voice back to our engineering team. So if you're having some challenges in doing container development or just development in general, on the cloud, be it our cloud or some other cloud, I want to hear from you and hear what those struggles are. Your job is to tell me, hey, I'm having a problem, and then I can go back to the engineering team and get those problems solved. So if you can't get those answers during this session, please reach out to me either on Twitter or in the hallway, and we can have those discussions and move forward. So here's a couple of the things that we're going to talk about today. Kubernetes service is our managed Kubernetes service on Azure. We've got container instances, registry, open service broker, and then some of the automation tools. And then there's going to be some other things we'll get to as well as far as tooling for Visual Studio Code, and some open source tooling as well. The first thing I want to talk about is the Azure Kubernetes service. This is our managed Kubernetes service that we have in Azure. And AKS reduces the complexity and operational overhead of managing Kubernetes, basically by offloading much of that responsibility to Azure, right? We will take the responsibility of starting that cluster for you and managing that hosted service for you. It handles the critical tasks like health monitoring and the maintenance for you. In addition, the actual manage of the service is free. The only thing you're going to pay for is the actual nodes that you're using. We've got flexible deployment options. It's got integrated logging and monitoring in the service. Automated upgrades and patches are on there. Easy cluster scaling, self-healing, all of the things you want from Kubernetes. We've got GPU-enabled nodes, HTTP application routing, and then also all of our development tool integration when it comes to doing Kubernetes the way that you want to do it on your cluster. Creating a cluster on Azure is pretty simple. If you've got the Azure CLI installed, it's as easy as doing AZ, which is our CLI command, AKS create, passing the name of your cluster, your resource group, and the location, and hitting enter. And this will create your cluster for you in Azure, and you're ready to go. If you didn't see this on Twitter today, it was announced that our AKS cluster is now GA. It is available today. I'm not announcing this. Brendan Burns announced this about 3 or 4 hours ago, but it is generally available in 10 regions. So if you want to take note of the URL that's there, the full blog post is generally available in 10 regions. And there's going to be more available as that comes forward. The next thing I'll talk about here is Azure Container Instances. Has anybody tried ACI? Right? This is the fastest way to get containers up and running. It's a great solution for any scenario that you can operate, any basic scenario that you can operate in isolated containers, right? Including simple application, task automating, build jobs. It's got fast startup times, public IP connectivity, DNS names, hypervisor level security. We do support Linux and Windows containers in ACI, right? We have a connector for our AKS service called Virtual Kubelet. What this allows for you to do is to use ACI as a back end for your nodes, for Kubernetes. We can actually use a Windows ACI connector or Linux connector for your cluster. And this allows you to fire these up fast. Some of the other uses for ACI, one of the things that I use it for is I upload a lot of images for processing for OCR. So I've got maybe 100, 200 images that I load up into my blob storage. I fire up an ACI container and I process those in an OCR, and then I burn down those containers when I'm done. I only pay for the time that those containers are actually running and not any longer than that. So batch processing, I do testing, other batch builds, so I can build my applications if I need to in CI/CD type of processes, but I'm only paying for when they're actually up and running. Fast way to create a container. Again, AZ container create, pass my group, my container name, and then the image I'm going to run. You can pull that image from Docker Hub, your private registries, and then pass a port. I'm passing port 80 in this example here. That makes that publicly available. And that image is ready to go. I've got a simple web application. This one here just happens to be, I believe it's a Flask app in Python, and it's available within seconds. That easy. The next service that we have here is the Azure Container Registry. It's a managed Docker private registry. It's a first-class resource in Azure. It's globally available. You can manage all of your images that you're going to be uploading. It makes a lot of sense for me to have my registry close to where I'm deploying my apps. Right? So if I'm running my AKS cluster in West US, I want to have my Azure containers registry in the same location. So when I'm doing my deployments, I have that quick network capabilities to deploy my apps. It uses the familiar open source Docker tools. I'm just changing where my actual registry is. Instead of Docker Hub, I'm using a different DNS name to pull those. Again, the registry is geo-replicated to all of our data centers across the globe. So those covers a couple of the technologies that we have across as far as our offerings. We also have things like Azure Web Apps for containers. If you're just running a single web application, it does support multiple containers as well. So you can also use that. If you have just simple web applications you're trying to lift and shift, we can do that too. You've heard a lot about application modernization. I'm sure none of you have old legacy apps, right? Right? We all have legacy apps that we're trying to lift and shift into the cloud. When you decide to modernize these apps and move them to the cloud, we don't have to fully modernize these apps, right? Modernization means that we're taking them apart, we're putting new features in them, sometimes rewriting them. Microservices is not always an option, and it might not be necessary. I know I've gone to business leaders and said, hey, I want to completely rewrite this app. And the first thing they tell me is, we don't have time, we don't have the money, and why on earth would you want to do that when it's not broken? So those are decisions that you have to make when you say, I want to move to the cloud. Do we transform it? Do we re-architect it? Do we do a partial modernization? Do we just pull out a piece of that service that makes sense? Maybe it's just the service itself. Maybe it's a WCF service. Maybe it's an HTTP service. Do we do a lift and shift? Do we just wrap that in a Docker container and move it up into one of those services we talked about before? Or can we do a full-on lift and shift? Maybe I'm just moving it to a VM. That's considered lift and shift, but do I get any benefit out of that? There's not a one-size-fit-all strategy to when we're doing these apps. Somebody in this part of the room can say, yes, I can move it to a VM and be just as happy. Somebody here can say, hey, I want to completely break it apart and put it in containers. I need orchestration. Somebody else can say, I need to completely rewrite the whole thing. Virtual machines is the easiest to understand. I think we all get that concept, right? We've said, hey, I can just take it from my garage and put it in somebody else's garage, and I'm happy with that, right? But we still have all the maintenance worries of doing VMs. I think we all get that. Containers is what I like to call a DevOps ready. If I put something in a container, I can push it to the cloud. I can start taking advantages of other things like CI/CD. I get the scaling capabilities. I can do orchestration, things like that. Our last option is the cloud optimizer. That's that full PaaS. I'm completely rewriting my app. I'm breaking apart all my services. I'm putting in multi-containers. We've had a lot of talks here at this DockerCon in the keynote talking about breaking things apart and re-architecting. Talking about .NET specifically, this first chart on the left is what an existing monolithic app might look like to you. Is anybody using .NET? So this might look very familiar to what we're at. We got web forms, MVC, some WCF. We've got maybe a relational database out there. That second chart is the infrastructure. That's where we're just moving it to a VM. And then the third one is that DevOps ready, which is kind of where I want to focus when we're talking about modernization of apps. That's where we're migrating our database over to SQL Server in the cloud, and then wrapping maybe our services in Docker, in a Docker container, and then pushing that to one of those other services. So we can do that using Visual Studio, where I can take a WCF service, using Visual Studio tools, adding that Docker container, pushing it over to Azure Container Registry, and then putting that in maybe ACI or into Azure Web Apps, and being able to take advantages of things like application insights, where I can add monitoring. I can start looking at Azure functions and eventing and adding those type of capabilities on top of that app when it's in the cloud. So let's take a quick look at what that looks like. Okay. So this is a WCF application. WCF users? Yeah, it's okay. You can put your hand way up. I use SOAP. SOAP is supposed to save the world. SOAP XML. I know it's WCF because this is a web config file, and I'm even afraid to mess this up because that's hours of me changing things. And I'm a little scared because it's got a star here. I'm like, oh gosh. Let's save and hope I didn't mess that up. Oh wait, look at that, there's an S. Okay, so right here, target framework is 4.5. So this is a simple WCF app. I wrote it 3 years ago. And all it does is give me a list of people, right? So in Visual Studio, we've got right click and I've got add Docker support. This is part of Visual Studio now. If I add Docker support to this application, maybe I didn't click the button all the way. We also have add orchestration support now too. So I can choose Docker Compose as an option. If I hit OK, it's going to do some things. It's thinking. There we go. So when I do this, it automatically knows that I'm using a WCF application. All right, it's inspected the type of app that I've got. It's added the proper from statement for me, so it's going to pull the WCF Docker image 4.71 Windows Server Core and start to build that image for me. All right. It also has the Compose project. In this case, for me, it doesn't do a whole lot of good because I have a single project. But if I had multiple projects, it would build those that Compose file for me based on all the projects in my solution. So if I go back to the Docker file, now that I have that built, I could run it. I have all the debug capabilities. I could put breakpoints, run this in Visual Studio just like I was if I wasn't in a Docker container, right? Which is great. Now that I have that done, I'm going to do something that some other people on my team don't like me to do, which is right-click publish. So if I do build and publish my app, I got some options here. I can push this right to an app service and run this right inside of Web Apps for Containers. I can push it to a container registry, so I can create a new Azure Container Registry right from Visual Studio. I can push it to Docker Hub or to a custom registry as well. So if I have an internal private registry that I've established, I have those options as well. Now I'm not going to do that now because this is a rather large image. It's Windows Server. It's a little larger than something like, I don't know, Debian or Linux, which is pretty small. But if I go up into Azure, here's the actual registry that I've created. And look at my repositories. Here's all the repositories I have. If I actually look for my WCF people for DockerCon. Here's the actual image that I've pushed over to ACR. Actually, let me find, I need to find my registry here. We need to find WCF people. So here's the actual image I've pushed up there. If I click on here, here's the tag. It automatically tags it for me, just like if I was doing it on a command line here. And then I can actually choose run instance. If I choose run instance from here, then I can choose to run it. I would obviously want to do it on Windows because I know it's a Windows-based image. Then I can run this in ACI right from the portal. Now, by doing that, here I've created that ACI container, just like I showed in the command line, which is the AZ container create. It does it from the portal here. And then right in my Azure container, here I am running the service. This is a WCF service running in Azure container instance without any code changes. All I did was wrap it, right? You can do this with any of your .NET 4.5 containers right from Visual Studio, right? Pretty easy. All right. Okay, moving on to some open source tools. Who likes to work on a command line? Everybody likes it. All right, so from the command line tools, what we have is a couple of things that we have built as a part of our Deis team that we acquired a while back, and we have Draft and Helm. So Draft is a product that's a streamlined Kubernetes from the command line, streamlined Kubernetes development. And Draft targets the kind of the inner loop developer workflow, kind of as you're developing your code, if you're kind of hacking on it, and it's before you commit your code to version control. So imagine you've got a development cluster that your team has put together for you to post your code to, or maybe you're just doing it on your local machine. You've got your cluster on Docker for Mac, and you're doing your development. I can, with a couple of commands, just push my code right to my cluster, right from the command line, and continue to make changes and continue to push that there just with Draft up, just by running that there. It automatically detects the language that I'm running. So I do Draft create on my project, and it knows that I'm running maybe .NET or Python or Node, and it will automatically create the Helm charts that I need to push that to the cluster, as well as the Docker file and Docker assets that I need. Helm is another project that we've basically pioneered and started, and it's been added as a top-level tool in CNCF at Microsoft. And this is a package manager for Kubernetes, basically. If I need to go out and find a project or a piece of software that I want to run on my cluster, something like Redis, I can go and search for that in Helm and find the charts and have that installed right on my cluster, right from the command line. And I can build these into my CI tooling as well. It'll manage all the complexity that I need to go find those charts. It'll describe how to install them, how to update them, how to delete them. And kind of takes all that pain away from also upgrading and rolling those updates forward. You can also create charts and upload those charts just same way you would do with something like, in the .NET world, a NuGet package. It also allows you to roll back and undo anything that you've installed via Helm as well. Again, a package manager for your Kubernetes clusters. So let's get an idea what that looks like. I'm going to have to speed up on this one. So I'm going to go over and I'm going to start with draft. Make sure that I'm in the right project. All right, so here I've got a simple Node.js app that really it's an Angular app with a Node.js front server. And I want to be able to push this onto my cluster. So I've done some development, and I just want to be able to put it on there. And you can see from the list of files on the left that I have nothing that has anything to do with Docker or charts or Helm or any of those things here. But I've got draft installed on my machine. So I just say draft create, and it's automatically detected that I'm running Node. It thought I was running HTML. It says, hey, I see it's got JavaScript. And then on the left, you'll see now it's installed, it's scaffolded out the Docker file, the draft ignore, Docker ignore. I don't want to deal with TOML files, thank you. And then all the charts that I need in order to install this on my cluster, right? I want to make sure that I'm working in the right cluster. Everybody knew you could do that, right? You can change your Kubernetes cluster with a little whale. All right, so now if I just say draft up, and I'm going to type in a little auto connect. It's going to build my Docker image. It's going to push my Docker image over to my Docker hub, and then push that onto my cluster. And then by passing the auto connect flag, it's automatically going to connect me with the standard out logs onto that application. So now if I browse to this location, now I'm running in the cluster, right? 2 lines, draft create, draft up, auto connect, and I'm running. Is that cool? Yeah, pretty nice. And I can do the same thing if I just change the line of code, hit draft up again, it's going to rebuild that image and push it back on my cluster again. And that's pretty simple, right? So that's draft. Now if I'm looking at Helm, let's go over here. Is this big enough for everybody? Yeah, okay. I said I can install Helm as a package manager, so then I want to go install Redis on my cluster. So I've got a running cluster, and I want to install Redis. But I don't know what Redis versions are out there, so I can do a Helm search. And I want to search for Redis. And I'm going to pass a -L flag because I want to see what versions are available for me out there. There's a lot of versions. All right, that's quite a bit of versions out there. What I want to do, just for giggles, is I'm going to install 0.10.1 on my cluster. So if I just, real quick, look at my pods. The only thing that I've got running right there is my web front end and a couple of masters. So that's the web front end I just deployed, but I don't have Redis running. So if I do Helm install, and I want stable Redis, and I'm going to pass a version flag. This will actually go and install that Redis onto my cluster. So if I look at here, and look at, so I'll alias that. You'll see that on the bottom here, it's called Ulterior Pike, is the name of our, I love the names it picks sometimes. All right. The ulterior pike is pending. So right now it's firing up our Redis cluster. And you'll see that here, our image is the Bitnami 3.2.9-R2. That's the name the image is actually installing right now on our cluster. So when I do an install, it gives me all of the information. Here's all the resources it's deploying, the name it gave us. Thanks, ulterior pike. And then also it tells me, hey, here's how you go get your Redis password. Here's how you connect. So this is all the information I need to do, need to have in order to work with this Redis installation on my Helm stuff, right? Pretty cool. So now that I have that, let's say hopefully it should be running. All right, looks like we're good. So now time flashes forward, boss says, hey, there's a new version of Redis, let's go ahead and update this guy. So I can say Helm upgrade. I can pass in, not that. I want ulterior pike. That's the name of my, there. And I want to pass in just stable Redis. And I don't have to pass in the version anymore because it's going to give me the latest. So let's look at this. So the container is still creating on the other one. It's a little slow. Hopefully this doesn't break anything. So now it's going to go ahead and upgrade. And you'll see on the bottom here, it's terminating the old one. It's creating the new ones. And I'm just doing a rolling upgrade with that package, right? Pretty cool. If I wanted to delete it, I would just do Helm delete and pass in ulterior pike, and it's going to take care of that, right? And you can do things with Helm and say, is there a latest version? You can run things in your CI program to go check and see if there's a new one, do those rolling upgrades, and you're all set to go with that, right? Pretty nice. All right. Next fun toy. This stuff is really exciting to me because there's a lot of fun toys. I get to play with these things all the time. You guys have to do the hard work. I get to invent this stuff. We're not invented. I get to play with it. So Azure Dev Spaces. Has anybody seen Azure Dev Spaces before? Just one person? Oh, this is going to be fun. Okay. So Azure Dev Spaces, it provides a rapid iterative Kubernetes development experience for your team, right? So creating microservices is hard. Not creating them, but developing and debugging and deploying is difficult, right? Because some of the stuff that I just worked on was really, I'm going to do some code, I'm going to do draft up, and it puts it up there, and I go, oh, bug. I have to change the code, and I have to push it up there again, and how do I figure it out? I'm doing standard out, I'm doing console write line, I'm doing all kinds of fun stuff, I'm checking logs if stuff breaks, right? What we've got now with Azure Dev Spaces is the ability to work multiple teams working inside of an AKS cluster with tooling inside of Visual Studio, command line tooling, or VS Code, multiple people working on the same cluster and not running over each other, right? But with also the debugger attached to your code running in the cluster. Does everybody believe me? I'm seeing blank stares like you're lying. Okay, not lying. Okay, minimal local machine setup. We'll do a lot of what you saw with the draft create, where we'll create those assets. It integrates with your AKS HTTP app routing, run any language, any framework, and also works on Windows, Mac, and Linux. So let's see what that looks like. Let me get out of this thing. I got 10 minutes. This is like trying to land a plane while it's flying. All right. Okay, so same application, Node.js, also running with Angular. And there's a ton of great tooling inside of VS Code and a command line that allows you to do local development, local debugging on your machine. But that's not the problem. The problem is when we're deploying these applications into microservices and in clusters, and trying to figure out how do we debug this stuff in an environment with the assets that are eventually going to be deployed into production, right? This works on my machine and is the same stuff everywhere. So we have the tool Azure Dev Spaces. So if I do, sorry, I got to remember the command, azds, Azure Dev Spaces, and I say prep, not there, prep, and I pass public. And what public does is it will scaffold out an ingress balancer for me to expose this service publicly. If you don't pass the public, then we'll give you a localhost endpoint that will open it up for you. So this does essentially what draft create did, where it gives me the charts, all your Helm charts for you, and again, that Docker file, right? So if I just say, oh, I gotta make sure I change to the right place. Put this in the right cluster. Okay. So now if I do azds up, this is actually going to take the files that are on my machine here. Come on now. There we go. This actually takes the files and puts them onto my cluster and will create the image on the cluster, right? So essentially I wouldn't have to have Docker even on my machine, right? So this builds the image and deploys the image onto the cluster, all in Azure. All right, so it's going to build the container image and then deploy that there. When I was testing this earlier, it says it takes 4 seconds. And it usually takes about 15. So we'll see. And again, this works with, right now, we have debugging support for .NET Core, Node, and Java right now, which is pretty good. And I'm sure there's going to be more languages and more frameworks coming. Come on. Go. This all has to do with your network connection. It's probably already built. It's the standard out that sometimes gets a little choked. There we go. See, the container took 2 seconds to build. So now it's going to be up there. Now I'm just waiting at this point for the container to start and gives me my address. So now the address is running, and let's click on this, and now I've done the same thing where I've done that. And that's a lot like the draft up, right? Pretty simple. But we have a VS Code extension, right? So if I do Command-Shift-P, we have this prepare configuration files for Azure Dev Spaces, right? Which will give me, in my debugger, launch program with azds. So if I click this now, this essentially does the azds up. And what I'll do is I'll go over to my files, go into my server.js, and I have a breakpoint set when it does the output for DockerCon. So again, same process where I'm synchronizing my files, building the container, deploying the container here. But at this point, I'm attaching my debugger to the code, the container that's running in my Kubernetes cluster in Azure. All right, this allows me to run and iterate on my development as I'm running in Kubernetes. Not on my local machine, but in Azure. The other thing that this Dev Spaces does is it allows me to create a space, meaning that if me and John are also working on the same application, he can create his own space. He'll just say azds space create John. And John can work on the same code base that I'm working on, but his own version. Think of it as kind of branching away his own version of a service. We're working on multiple services, microservices. He can take a hotel space, and I can take maybe the reservation space. And all the routing will still work in the cluster, but we're not stepping on each other, right? Which is kind of nice. So now that this is run, I'll go through some slides. We've got about 5 minutes that shows that. So as soon as, I'm just waiting for it to give me the go-ahead output. We're waiting for it to attach to the debugger here. This is ingress. We're waiting for you, ingress. So yeah, so John and I can work on the same code. He can create his space, and then he can work on his portion of the service. I can work on my portion of the service, and we're not stepping on each other. If he checks in code, I will get the latest version of his service that he's working on if I choose to work through his space. But we're both working in the same cluster, which is great. There we go. Now we're working. And it's hit my breakpoint here. So now I'm running in the cluster, and I'm getting all of the things that you would expect from my breakpoint. So if I go over to my debug, here's my call stack. I'm getting debugging, and this is the debugging coming right from the Kubernetes cluster, right? That's pretty cool to me. All right. So real quick, talking about those spaces. Like I said, microservices are hard to develop. This is kind of our traditional environment that we're used to, right? Everybody's kind of working on their local development machine. They're doing check-ins. It's going to your CI/CD, and then that gets into the environment, and it goes to those environments where you're testing. The problem is you have to have some knowledge about how to set up all that microservices stuff on your machine, and hopefully you have some idea of how that stuff works, how to get it all set up, and hopefully you can run all that chain dependency on your machine. Same scenario, the assumptions again, you hope you know the full dependency graph. You can set up those services. Again, hopefully you can run on your laptop. The other option is you can create mocks for all those services. I don't know about you, but sometimes those mock services become your job, right? How many times have you guys, your code has gone bad just to find out that the mock service was the one that was wrong, right? So here I get to work with the actual services. So think about that too. This is what I was explaining before. Like Lisa has her own space. She can create her own dev space here. And then she can work on the front-end service in the cluster. And then John's got his own space as well, where he's working on maybe just the promotions DB in the cluster itself. And then you'll see that little line underneath where it says John's dev space. So as the app comes in and does the routing, we're not stepping on each other, but we're still working in the same development cluster. We can collaborate in the same cluster. If I'm in the code, in the actual cluster here, let me get out of this here, and I look at AZDS space list, you see that there's a default, which is the main line, and then I have a dev list. So I'm working in the dev list, in a dev space. Somebody could be working in the default stuff as well. And I say, hey, John, I've got a problem with this. And I say, what space are you in? He can switch to the dev space, and now we're working on the same stuff. And we can see what's going on in that particular branch, right? But he can say, fine, I'm going to go create my own. And I can say AZDS space create and pass a name, Shane. So now it's going to create my particular space, right? And I can do that same command again. So now it's made a new space for me, Shane, and now I'm working isolated to me with this same code. I'm not branching code. I'm not creating a new branch in Git to work with something else that nobody else can see, but I've made a space in my cluster that I can work with and not affect anybody else while I'm making those changes. I can fix it, check in the code, everybody's happy. All right. So real quick, I want to get to the most important slide. Talk about collaborating in the cluster and how that kind of works. This is probably the most important slide to take a picture of. This is everything I've talked about. I've really kind of had to skip the rock across the lake and hopefully get you guys a little excited about some of the things we have to offer. Azure Dev Spaces, it's in preview right now. The docs are available. Go to docs.com and you can find that. Try Azure with Docker. It'll get you to our container space. And there's some other great resources up there. If you have any questions, please hit me on Twitter, find me in the hallway. I'll also be downstairs in the booth. So thanks for spending your time with me.